Find the equation of the tangent line to f of t equals 2 over t at not x equals 2, but t equals 2. So we're using t now instead of x. So first of all, let's remind ourselves of what the equation of a line looks like. The equation of a line is y is equal to ax plus b, where a is equal to the slope of the line, and b is equal to the y-intercept. So when x is equal to 0, y is equal to b. So in order to find this equation for a line, we really have two options. Knowing 2 points on the line, that's definitely enough to find the equation. But knowing the slope and 1 point is also enough to find the equation. So we need either 2 points or slope and 1 point. Well, you can guess that since we've been working with derivatives and we've learned that derivatives and slope are the same thing, we're going to end up with the second thing. We're going to have to find the slope and 1 point. So if we're asked to find the equation of a tangent line, our first step is going to be the same thing as it was up above, to find that f of x plus h, because we need to find the derivative in order to find the slope. So I'm going to name these steps a little bit differently because the question is a little bit different, but ultimately we're going to be doing the same thing that we've been doing with just a couple extra steps. So my first step is going to be to find the derivative of the function in order to find the slope. In order to find the slope. And so in this case, later we're actually going to learn lots of different ways to find the derivative, but right now we only have the limit definition. So we're going to start by doing our limit definition step. So our first step here, so ultimately the first thing we're doing, is that f of x plus h. Only in this case, I'm using t and not x, so I have f of t plus h, which means I just replace that t with t plus h in parentheses. In this case, though, those parentheses turn out to not be important. I'm just dividing by t plus h. Having them on the bottom shows that I'm just dividing by t plus h. I'm not like subtracting it, I'm not squaring it, I'm not multiplying it by 2, so I'm not actually doing anything to it. So I don't need the parentheses. So then I'm going to put it into my limit definition of the derivative. I'll just remind us, f prime of t will be the limit as h approaches 0. Instead of x, we have f of t plus h minus f of t all over h. So that's the definition that I'm plugging into. So I'll have f prime of t is equal to f of t plus h, so it's 2 over t plus h, minus f of t, that's 2 over t, all over h. Now, I want you to take a look at this. Does that look right? Did I do everything okay? No, I have to write the limit sign. It's not just this thing. It's the limit as h approaches 0 of this thing. So it's really easy for some reason for people to forget that limit. So be careful. The limit definition is a limit definition and involves a limit. When you're evaluating this, it involves a limit. If you don't have the limit, you might have h's left over. We don't want that. So now we're going to have 0 over 0. We're going to be looking for that factor of h to cancel out. And we have fractions inside of our fractions. We have complex fractions, so we can see that we just have to multiply by the denominators of the small fractions that are inside the bigger fraction. So in other words, I'm multiplying by t plus h times t over t plus h times t. So then this is equal to the limit as, not t, as h approaches 0 of 2, in that first part the t plus h's cancel out, and I'm multiplying by h, minus 2 in the second one the t's cancel out, and I'm multiplying by t plus h, over h times t plus h times t. Now, at this point, you might be like, yay, let's cancel, goodbye H, goodbye H. Don't do it, bad plan. Why is that a bad plan? That is a bad plan because H is not a factor of the numerator. That H on top, it's not H times other things, it's H minus other things. It's being added or subtracted to other things. It's not a factor. I'm not at a point yet where I can cancel out. So instead, I'm going to distribute that minus 2, and I'm going to try to find a factor of H in the numerator. And I just wrote that wrong. I'm sorry, guys. That's a T here, not an H. Let me change that color. That should be T. That should be T. I wrote that wrong. Sorry about that. So that H right there is T plus H times T. And notice those two T's minus 2T is 0. So I can just cancel that out and have this is equal to the limit as H approaches 0 of minus 2H over H times T plus H times T. So the fact that that's a T is definitely another reason that you should not cancel those H's out, but also you can't cancel these H's out, and you can't cancel the T plus H out. That T plus H is being subtracted. It's also not the factor you're looking for. Remember, control yourselves. Wait till you have the H. So like there's nothing we can do except say 2T minus 2T equals to 0. And now H is a factor. Those cancel out. The limit as H approaches 0 of negative 2 over T plus H times T. Remember, I am plugging in 0 for H. In this case, not T, not X, not anything, just H. So then this becomes negative 2 over T plus 0 times T, which gives me negative 2 over T squared. So F prime of T is equal to negative 2 over T squared. That's my derivative. And then my third step is to plug in the value in question. So here we're at our third step. And this is our third sub-step of step 1. We're just finding our slope here. So f prime of the t value we were given is 2. F prime of 2 is equal to negative 2 over 2 squared. That's negative 2 over 4, which is negative 1/2. So that is the slope of the tangent line. Now, the second step is sometimes not necessary. So this is like my big step 2. And this was my big step 1. I'm going to kind of change it not to be in red there. This is now find the y value of the point, if not given. So here, what I'm told is that I have the function 2 over t. So 2 over t is going to look something like this, where I'm told that I'm looking for the equation of the tangent line at 2. So in other words, I know that the slope of this line is equal to negative 1/2. But you'll notice that that point there is also on the line. It's on my tangent line, but it's also on the function. So here we have a point on the tangent line and on the function. So to find the y value of my point, I know the t value is 2. I can just plug it into the original function, not to my derivative. My derivative gives me slope. My original function gives me a y value. So find the y value of the point, if not given, by plugging in to the original function. And now if you understand what's going on, this should make sense. Derivative is slope. We plug into the derivative to get the slope of the tangent line. That point is on the tangent line, but it's also on the original function, so we plug into the original function for that. So now I'm doing f of 2, which is 2 over 2, which is 1. So my point here is 2, 1. So now I have my point. Sometimes we're going to skip step 2. Sometimes we'll already be given the y value, which brings us on to our step 3, which is to plug into the line to find b. So plug into the line to find b. So to find b. So in other words, I have y is equal to ax plus b. Well, now I know that my slope is negative 1/2 x plus b. So I'm plugging in the point to this. So I replace this with a slope. And now I want to plug in the point, which is 2, 1. So that means my x value is 2, my y value is 1. So I have negative 1/2 times 2 plus b. And I get that b is equal to 1 plus 1, which equals 2. And my line is therefore negative 1/2 x plus 2. That is the equation of my tangent line. In other words, this line that I drew right here, this is y is equal to negative 1/2 x plus 2. That is the equation of the tangent line. Be careful, solving for b is not the last thing you do. Plugging b in is. Make sure that you conclude by giving the actual equation of the line. Make sure you conclude by giving the actual equation of the line. So there's another way that we could do this, and honestly, I think that what we just did is probably the most straightforward, the straightest, the easiest, but sometimes you'll be specifically asked for the line in point slope formula. So if you have the line in point slope form, a line in point slope form would be like y minus y1 is equal to a times x minus x1. So this is just another way of writing the line where that a right there, that's my slope, and x1, y1 is my point. So in this case, the point slope form of this same line would be y minus my y value, that's y minus 1, is equal to negative 1/2 times x minus my x value, that's 2. So this is the point slope form of the line. And so another way that I could do this, if you're specifically asked for the point slope form, that's fine. But usually we want the slope intercept form. So we could actually solve here and say y minus 1 is equal to negative 1/2 x plus negative 1/2 times negative 2. So y minus 1 is equal to negative 1/2 x plus 1. And when I add 1 to both sides, notice I end up with the same line. So I get y is equal to negative 1/2 x plus 2. So this is another way that you could solve for the line if, for example, you are more comfortable with the point slope form. That said, you are specifically sometimes asked for the point slope form. You should know it. Well, you should be able to recognize it at least. Anyway, so that's how we could alter this problem a little bit to actually find the equation of the tangent line. But notice, the first thing I still did was the same thing as we did in the previous problems. I find the derivative using the limit definition, use that to find my slope, then I find a point and plug in to get my line. That's all. Bye.